Hello. So in this video, we'll be starting with the solving of previous year questions, and we will take like very previous year questions where let's say in this question this was in around 1970s and in 1990s where we also had questions of 1 mark. So it's not that if the questions are so old then the questions would not be repeated. The questions are likely to be repeated, or at least the idea of the question is likely to be repeated. Okay, so fine. So let's start with this question. Now, in the question, we have the number of neutrons in a dipositive zinc ion with mass number 70 is. Okay, so I have zinc. So what I have, what I should know, what is expected in this question, we should know all the D block elements. So we have scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, and zinc, right? Now, scandium is 21 and zinc is 30. So the atomic number of zinc is 30. Now, we know that the atomic mass number, which is denoted by A, is equal to number of protons plus the number of neutrons. Okay, so the number of protons is equal to the atomic number. So atomic mass number is equal to Z plus number of neutrons. Okay, now what I know the atomic mass number, which is equal to 70. And atomic number is something which is expected, which we should know. It is 30. So the number of neutrons would be what? So the number of neutrons will be 70 minus 30, and this will give us what? Number of neutrons is equal to 40, right? So the correct answer to this question is option D. Fine. The next question. So I have two small questions. So this is a reason why I have clubbed them in one page. So if you see in the first question, it is asked Rutherford's experiment of scattering of alpha particles. So alpha is actually written small, which is misprinting. It is alpha particles showed for the first time that the atom has. So what did Rutherford's model actually told us? Rutherford's model told us that we have a nucleus and we have protons concentrated in the nucleus, and then we have the electrons revolving around the nucleus like the planets revolve around the sun. So this was the first time when we got to know that there is some region where all the protons are concentrated, and to which he called as nucleus. So the first time that we got to know about nucleus was through Rutherford's experiment. So the correct answer to this question is electrons were known before, the protons were known before, and the neutrons although were known later, but they were not known by Rutherford's experiment. So the right answer is nucleus. Then any p orbital can accommodate up to. Okay, see, now there are two things. Now what is asked here? P orbital. Okay, now there is one, like I have also told in my previous videos, there are things like a subshell, which is denoted by L, and there is an orbital. The number of orbitals are known by the values of ml, which is a magnetic quantum number. Okay, so a subshell L, if it is equal to 1, then it is a p subshell. Okay, so it is a p subshell, and we know that in a p subshell we have 3 orbitals. Okay, so -1, 0 and 1 are 3 orbitals. Each orbital has what? An occupancy, a maximum occupancy of 2 electrons. So this is given by what? This is given by Pauli's exclusion principle, right? So Pauli's exclusion principle says that no two electrons can have all these 4 quantum numbers same. So this is where we got to know the maximum occupancy of electrons in an orbital. Okay. Now what is asked? It is not asked about the p subshell, rather the p orbital. So any orbital, be it p, f, s, d, will have how many? The maximum occupancy will be what? 2 electrons. So p orbitals will have 2 electrons. Now the 2 electrons, if you see in the option, so we have two options with 2 electrons. If you see, one is with 2 electrons with parallel spin, and the other one is 2 electrons with opposite spins. So if you see, if you know, since all the 4 quantum numbers cannot be same, the spins are different. And the spins are different means what? Both the electrons have opposite spin. So we have learned that the spins are ms values for the two electrons is equal to plus half and minus half in the same orbital. So the spins are opposite. So the right answer to this question will be option D. Okay. So option D, two electrons with opposite spins. The next, the principal quantum number of an atom is related to the principal quantum number we know is n. So n is related to what? So we have learned this in the videos that the n is related to the size of the orbital. As the value of n increases, the size increases. Let's say n is equal to 3 has a larger size orbital, then n is equal to 1. So if you look at the other options, spin angular quantum number is given by what? It is given by the value of ms. Okay. So this is given by value of ms and not the value of principal quantum number. Then orbital angular momentum is given by L. Okay. So this is also not the right answer. And then orientation of the orbital in space is given by the values of magnetic quantum number. So the right answer is the size of the orbital, which is given by a principal quantum number. In the next question, Rutherford's scattering experiment is related to the size of so the scattering experiment means the experiment where he told about the structure of the atom. So the scattering experiment where the alpha particles, if you remember, so what we have in the scattering experiment, so Rutherford experiment, why it is called a scattering experiment? Because alpha particles were bombarded on the thin film of gold foil, and then these alpha particles were scattered at various angles, right? And some were also scattered back. So this is a scattering experiment. So what does this scattering experiment tell us about? The scattering experiment told us about the atom. Okay, so this was actually explaining about the size of the atom, right? So the Rutherford's experiment, what it was telling us, it was actually telling us that there is a nucleus because of which the nucleus size and all the protons are concentrated in a small size, due to which there is a lot of empty space and most of the rays are going unscattered. Only few are scattering back. So this was actually aiming on what? It was actually aiming on the nucleus, and therefore the scattering size is related to the size of the nucleus, where it could actually tell us the size of the nucleus in the Rutherford experiment. It was around in the order of 10 to the power minus 15 of a meter. Okay. Now the increasing order lowest first for the values of E by m, which is charge to mass for electron, proton, neutron and alpha particle is. So we have to find what? The charge to mass ratio. So E by m is equal to charge upon mass. Okay. So we have to find for each. Let's say the mass is, mass of a proton is considered as standard. So mass of proton is equal to 1. Okay, if we should not go into the actual values of mass are also known, but here we are expected to know this thing. The mass of proton is, let's say, 1, and mass of neutron is also almost equal, which is equal to 1, and the mass of electron is equal to what? It is around 1 upon 1837 times mass of a proton. Okay, but then what is mass of a proton? Mass of a proton is 1, so 1 upon 1837 times of 1. So this will give us what? This will give us mass of the electron is equal to 1 upon 1837. Okay. So we know all the three masses: mass of electron, mass of neutron and mass of proton. Now we find out the values. So let's say the first one is for electron. So for electron, what is the value of charge? Charge is equal to 1. Okay. So the charge is equal to 1. And if I talk about the mass is what? 1 upon 1837. Okay, so this will give us what? Whenever we have a fraction in the denominator, it will multiply as its reciprocal. So this will be 1837 upon 1. So what does this give us? This gives it 1837. Okay. So the value for this is charge by mass ratio. So E by M ratio for an electron is equal to 1837. Okay. The second one that they are asking is for a proton. So for a proton, the charge is equal to 1 and the mass is also equal to 1. So this is what? This is equal to 1. Right? Then the third one is neutron. So neutron is what? Neutron has a charge of 0. Neutron is neutral. It does not have a charge and it has a mass of 1. So this will become what? 0. And the fourth one that we have is an alpha particle. So the alpha particle has what? Alpha particle has 2 protons and 2 neutrons. Okay. So if I take the total charge, so what will be the total charge for an alpha particle? Total charge will be equal to, only for 2 protons, so this will be equal to 2. And the total mass will be equal to how much? Total mass will be equal to the total mass of 2 protons plus 2 neutrons. So 1 proton is 1, mass is 1, and for 1 neutron also the mass is 1. So this becomes what? 4. So this is equal to 4. So if I find out this ratio, so this will give me what? Charge by mass, or which is also called as E by M ratio. So this will be equal to 2 upon 4, which is equal to 1 upon 2, which is equal to 0.5. So these are the values of charge by mass ratio for different particles. Now what we have to do, the increasing order, which means the lowest value first. So the lowest value is for a neutron. Okay. So the neutron will come as the first. We have 3 options where we have neutron as first. The second that we have is an alpha particle. So after neutron, there will be alpha particle. So neutron will be the lowest value. Okay. So what is the lowest value of neutron? Which is 0. Then alpha particle will have the next value, highest value, which is 0.5. Then proton is 1 and electron is 1837. So from lowest to highest, this is the right order, and therefore B is the right option. Okay. Then the set of 4 quantum numbers for the valence electron of rubidium. Okay. So are they expecting you to know what are the atomic numbers? No, because they have already given us. So what are they expecting here? They are expecting to know the Aufbau drawing, the Aufbau principle of filling of electrons. So if I draw the Aufbau principle. Okay. So what will we fill? We'll just start filling the electrons, and what will we do? We'll just count how at what point do we reach atomic number is equal to 37. So we'll fill 1s2. The next that we are filling is 2s2. So I'm using the Aufbau principle. Then I'll be filling 2p6. Then 3s2, 3p6. Then after 3p we have 4s2. Then after 4s2 we have 3d10. So till here we'll count how many electrons have we filled. So 2 plus 2 becomes 4, plus 6 10. 10 plus 2 is 12. 12 plus 6 is 18. 18 plus 2 is 20. 20 plus 10 is 30. So we have filled till 30 electrons in the 3D. Now the next that we'll be filling is in 4p. Okay. So in 4p what will we get? 4p6. So till here it was 30. Then till here this becomes 36. Okay. Now the next electron that will come, we have total 37, will be in the 5s. So it will be 5s1. Okay. So if I want to find out the quantum numbers, so so we are asked for the outermost quantum number. So n will be equal to 5. Then s, so for s the value of L is 0. Then the next thing that is asked is so the value of ml. So the value of ml for L is equal to 0 is also 0. And the value of spin can be plus half or minus half. But if you see in all the 4 options, the spin values are given as plus half. So we don't have to worry about the spin values because we are not given a confusion between plus half or minus half. So let us consider that as plus half. Okay. So all I have to do is I have to match these values with the options. So in the options, we have these values in which option? We have it in the first option. The right answer is option A. Now the next question is, which electronic level would allow the hydrogen atom to absorb a photon but not emit a photon? So what happens in absorption and emission? Let's say if I say that there are levels. So these are various shells. Okay. Now let's say this is the nucleus and the electron is present in the first shell. So n is equal to 1. when electron absorbs energy, it goes to a higher shell. So it can go to n is equal to 2 or n is equal to 3. Okay. So this process where the electron absorbs energy and goes to a higher shell is known as absorption. So at this process, it can absorb a photon. Okay. Now on the other hand, let's say if the electron is present in a higher shell. Okay. So electron is already present in the higher shell. So now from the higher shell, it can go to a lower shell, and the lower shell has lower energy. So in such a process, what will it do? It will emit a photon, and this is known as emission of photon. Okay, so these are the two processes. Now the question asked is, in which of the electronic level the hydrogen atom would absorb a photon but not emission? So absorption is possible, but emission is not possible. So this is what we have to find out. Now let's say if I consider the 3s. So 3s means a third shell, principal quantum number n is equal to 3. From n is equal to 3, if the electron is present, the electron can still move to higher shells because we still have higher shells, like we have 3p, then we have 4s and 3d. So electrons always, when there are orbitals present in the higher energy levels, there can always be absorption. Now when I talk about emission in the 3s, yes, from the 3s it can go to lower energy levels, let's say 2p or 1s or 2s. So 3s can do both. Then if I consider 2p, 2p also has energy levels which are below the 2p and which are above 2p. So above 2p will help in absorption. So 2p has shells above which has 3s and 3p. So the electrons can absorb and go there. And 2p also has levels in the lower energy levels. So it can emit energy and go to these levels. So both is possible. Now if I consider 2s. So 2s has what? 2s has energy levels lower and also has energy levels above. So 2s can absorb energy and go to higher energy levels and can also emit energy. And if I talk about 1s, so 1s is the lowest energy level that electron can have. So from 1s, it can always go to 2s, 2p or any higher energy level. So this is possible. So absorption is possible. But what we see, the emission is not possible. Where will it emit? There is no other energy level lower than this. So in such a case, what we have, a 1s is a level where the photon can be absorbed but cannot be emitted. So the right answer is option D. Then the Bose model can explain what? Bose model, if we know, it explains the spectrum of an atom, of hydrogen atom only? No. But we also had one electron atoms too. So one electron atoms were also explained by Bose. So so the spectrum of hydrogen only is not completely right. The spectrum of an atom or ion containing one electron only is right, because this is what we consider the one electron systems, where we could derive energy levels and the radius values from them. So let's say if we had a beryllium 3 plus or a helium 1 plus, so we were able to consider these, considering that the values of energy was some value of Rydberg constant into z square upon n square. So we could consider z square provided that it has only one electron. Then the spectrum of hydrogen molecule. So the only mistake in this is it is molecule, but we cannot find for molecule. We can find for an atom. Then the solar spectrum is definitely not the answer. So these are not the answers, and the right answer is option B. Then the radius of atomic nucleus is in the order of. So atomic nucleus, now you have to remember these two values. These are repeatedly in some way of the unit or some other is asked. So the radius of atom is 10 to the power minus 10 of a meter. Okay, and radius of nucleus is 10 to the power minus 15 of a meter. So we can see that the nucleus is very smaller than the atom. Now if you had remembered these values initially, so without even looking at the units, one would make a mistake of marking the option C, because the radius of the atomic nucleus is asked. But if you see the units, here it is centimeter, and the units in which I have mentioned is meter. So what we have, all the units are in centimeter, so they expect to know this conversion. So if I want to convert meter to centimeter, what I do, I will multiply by 10 to the power 2. Okay. So I will multiply by 10 to the power 2 centimeter per meter. So meter and meter get cancelled. So 10 to the power minus 15 plus 2 becomes what? So minus 15 plus 2. And this will give us 10 to the power minus 13 centimeter. Okay. So the right answer is 10 to the power minus 13 centimeter, which is option B. In the next question, electromagnetic radiation with maximum wavelength is. Now in this, it is expected, if you see from this question, that we should know the you know like the spectrum, the electromagnetic spectrum, and we should know how the wavelength and the frequency are, like at which point or at which terminal the wavelength is higher and at which terminal the frequency is higher. Okay, so this is something which is expected from you. Now to have a look at the at the range of what the different levels stand at, I will write those levels for you, but then it is again always expected in some form of the other, the questions are asked with respect to this. So always remember that you should learn these values or these range. Cosmic rays, cosmic rays, gamma rays. Now maximum wavelength is asked. So with respect to wavelength and with respect to energy, I will tell you. Then we have X-rays, then UV rays, visible, IR, which is called as infrared radiation, and radio waves. Now, one more relation that you have to remember, that energy is inversely proportional to wavelength. So if the wavelength is higher, the energy is smaller. Okay. You have to remember this, that the energy of the cosmic rays is the highest, and also of the gamma rays. Gamma rays are used to kill bacteria. So it has very high energy. So if you see that the energy values are high, so the energy values are lower for radio waves, the lowest, and the energy values are highest for cosmic rays. Now, if this is how the energies increase, the opposite will the wavelength increase. So the wavelength will increase in this way because the wavelength is inversely proportional to energy. So the wavelength will be lowest for cosmic rays and the wavelength will be highest for radio waves. Okay, so this is what is asked in the question with maximum wavelength. So maximum wavelength will be what? Radio waves, and the answer is option B. Okay. So the Rutherford's alpha particle scattering experiment eventually led to the conclusion that. So what were the conclusions of Rutherford's model? So the mass and energy are related? No, we didn't have any such conclusion. Electrons occupy space around the nucleus? Yes, this was a conclusion where it said that electrons are present in various orbits which are surrounding the nucleus. So yes, electrons occupy space around the nucleus is the right answer, is one of the right options. Neutrons are buried deep in the nucleus? No. Rutherford's model did not tell us about the neutrons. So Rutherford's model, when it came, it only spoke about electrons and protons. And till that time, there was no any such fact where they could find out the neutrons, and Rutherford's experiment couldn't find that. So the option C is not right. The point of impact with matter can be precisely determined? No, this was also not the right answer. So the right answer is option B. Which one of the following sets of quantum numbers represents an impossible arrangement? So to understand this, let's just quickly revise what are the rules. So whatever we have, we can have the values of n, let's say from 1, 2, 3 and so on. Then the values of L is n minus 1. So whatever is the value of n, in whatever is given, like say here, n minus 1 should be the value of L. Then what can be the values of Ml? The values of Ml can be from minus L to 0 to plus L. Okay, so these are the values of Ml, and then Ms for every orbital. So this would be one orbital. For every orbital, it will have a minus half and a plus half value. Okay, so this is what we'll be confirming for every question, I mean every option. So let's say if I take the first one, so we have n is equal to 3 and L is equal to 2. So this is acceptable because L is what? N minus 1. So this is n minus 1. So this is 3 and this is 2, acceptable. Then ml can be what? Ml can be minus L2 plus L. Okay. So ml is -2. So this is one of the values which ml can take from the values of L, acceptable. ms is half. So each orbital will have both the spins. So this is acceptable. What we are asked? We are asked in impossible arrangement. Then for 4, we have values. Okay. So what are the values of L actually? So L can take values from 0 to n minus 1. Okay, so if the value of L is if the value of n is equal to 4, then what values can L take? So L can take 0 to n minus 1, which is 3. So it can take 0, 1, 2 and 3. Okay, so 0 is an acceptable value. Then the value of ml can be what? Ml is from minus L to plus L. So the maximum value of L is -3. So what can be the value of ml? It will be from -3, -2, -1, 0, 1, 2, 3. So if you see 0 is a possible value with ml, yes, and plus half is also possible. So this is also an acceptable answer. Then if we have the value of n is equal to 3, then the value of L is equal to 2 is acceptable. So if the value, so what will be the values of L? So this will be 0, 1, 2. So the maximum value of L is 2. Now if I want to find out the values of ml, so it will be what? Minus L to plus L. So the maximum value is -2 and in the minimum -1, 0, 1 and 2. So these are the values of ml. Okay, but if you see the value is -3. -3 is not included in this. So this is not a quantum number which is acceptable. So this is an impossible arrangement and this is our right option. Okay, similarly we can do this for fourth, and definitely fourth option will also satisfy. So I leave the fourth option up to you. You can verify for yourselves. Okay. Next, the ratio of energy of a photon of 2000 angstrom wavelength radiation to that of 4000 angstrom radiation is. So this is what they are asking. Now what we know, so the relation is asked between energy and wavelength. Okay, so one relation that we know is energy is equal to h nu, or nu is equal to c, which is speed of light upon wavelength. So energy is what? Energy is hc upon wavelength. Okay, so other terms being constant, when the wave energy is changed, the wavelength will change. So what I understand that the energy is inversely proportional to wavelength. Okay, so if this is the case, then if I have ratio of two energies and two wavelengths, what will I get? So let's say if I have a ratio of E2 upon E1, then the energy will have an inverse relation. So it will be lambda 1 upon lambda 2. So what is asked? The ratio of energy of a photon of two different wavelengths is asked. Okay, so the first is 2000 wavelength relation to that of 4000. Okay, so this will be what? 2000 upon 4000. Okay, so this is asked. So the energy of 2000 wavelength is what? So let's say if I write energy of 4000 upon energy of 2000, this will be what? Wavelength of 2000 upon wavelength of 4000, right? Now they have asked the ratio of energy of a photon of 2000 versus 4000. So the energy ratio is what? It is asked energy of 2000 upon energy of 4000. So I'll have to take a reciprocal of this. So if I take a reciprocal of this, I will also have to take a reciprocal of this. So energy of a 2000 wavelength versus energy of 4000 wavelength. So I'll take the reciprocal of the right hand side too. This will be wavelength of a 4000 upon wavelength of 2000. So what is the wavelength? It is actually 4000. So energy of 2000 upon energy of 4000 is equal to 4000. So after this I am continuing to this point. 4000 upon 2000. So this is what? 2. So energy of 2000 wavelength versus energy of 4000 wavelength is 2. So the right answer is option D. Okay. Now the triad of nuclei, that is isotonic. Now what is isotonic? Isotonic means having the same number of neutrons. Okay. So this means same number of neutrons. Okay. So we just have to check the number of neutrons. So let's say in the first option we have carbon, nitrogen and fluorine. So what we have, 14 is the atomic number, 6 is atomic mass number, 6 is the atomic number. So number of neutrons if I have to find, so what is the relation that we did this relation in the previous question. So number of neutrons plus number of protons is equal to atomic mass number, which is A. So if I just have to find out the number of neutrons, this will be mass number A minus number of protons. Okay, so number of protons is 6 in the first case, and so this is the atomic number is also the number of protons, and the atomic mass number is 14. Okay, now I'll just have to subtract these values. So this will be what? 14 minus 6, which is equal to 8. Okay, so for the first case the value is 8. Then for the second case, so nitrogen 15 and 7. So this will be what? 15 minus 7, this is also equal to 8. So the number of neutrons is 8. And the third one, fluorine 17 and 9. So this is 17 minus 9, which is also equal to 8. Right? So the right option to this question is option A, where all of them have the same number of neutrons and therefore they become isotonic. In the next one, which of the following sets of ions represent a collection of isoelectronic species? So what is isoelectronic species? Isoelectronic species means the same number of electrons. So we aren't considered about the atomic number, but we are considered only about the number of electrons. So same number of electrons. Okay. Now which of the following species represent that? Okay. Now I will just keep finding the number of electrons. So let's say if I have in the first one N3 minus. Okay. So N3 minus is what? The atomic number plus extra electrons, which is 3. So this is equal to 10. Then I have O2 minus, which is atomic number plus 2 electrons, which is a charge, which is 10. Then F minus is atomic number plus 1 electron, which is 10. And sulfur 2 minus is atomic number. So the atomic number of sulfur is equal to 16. And 16 plus 2. So 16 plus 2 is equal to 18. So all three could follow, but one didn't follow. So the next option we have lithium plus, which is what? Lithium has in total 3 electrons minus 1, because there is 1 electron that is taken off, so this becomes 2. Then sodium plus is equal to 11 electrons minus 1, which is 10. So in the first two options itself, we could see that there aren't same number of electrons. So this is B is definitely not the option. So if I look at C, so I have potassium plus 1. So what is the potassium? Potassium is atomic number 19 minus 1 because of plus charge. So we have 18. And then we have chlorine minus. So chlorine atomic number is 17. So 17 plus 1 because 1 electron is added. So this gives us 18. Then calcium 2 plus calcium atomic number is 20. So 20 minus 2 because 2 electrons are taken off. This also gives us 18. And scandium. So scandium atomic number is 21. 21 minus 3 electrons. And there are 3, right? Yeah, so that the charge is 3. So scandium plus 3. 21 is the atomic number minus 3, which gives us again 18. So if you see, all the 4 have same number of electrons. So the option C is the right answer. In the next one, which of the following sets of quantum number represents the highest energy of atom? So the highest energy of atom is what? Decided by what? Decided actually by the principal quantum number. So high value of n means high energy. Okay. So if you see in the options, n is equal to 3 in the 3 options, right? Or either rather just saying by value of n, it is actually what? Like the Ogba principle is based on what? High value of n plus l. So n plus l has to be considered and only then high value. So all I have to do is I have to just find the n plus l values for all the options. So if you see in the first option we have 3 and l is equal to 0. So this gives us 3. In the second option we have 3 plus 1. So this gives us 4. In the third option we have 3 plus 2, which gives us 5. And in the fourth option we have 4 plus 0, which gives us 4. So if you see, the third option has the highest value of n plus l, and according to the Aufbau principle, the highest value of n plus l has the highest energy. So C is the right option. Okay. Which of one of the following constitutes a group of isoelectronic species? Right. So if you see, there are a certain species whose configurations we have to, or the number of electrons is what we have to find. So we have C2 2 minus, then okay, we'll find each of them one by one. Then we have O2 minus, CO, NO, then we have NO plus. So C2 2 minus we are again finding anyway. Then we have Cn minus, and then we have N2. We then also have Cn minus, then N2 we have found, O2 2 minus, then C2 2 minus we anyway find it, then N2, O2 minus, NO plus, and CO. Okay, so we have to find out the number of electrons for these species. So C2 2 minus is what? So carbon is 6. So 2 carbons will be 6 plus 6, and there are two added electrons plus 2. So this gives us what? This gives us 14. O2 minus is what? Oxygen is 8. One added oxygen is again 8, and one added electron for the charge. So this gives us what? 17. Then carbon and oxygen is, carbon is 6 plus oxygen is 8. So this gives us 14. Nitrogen and nitric oxide is, nitrogen is 7 plus oxygen is 8. So this gives us 15. NO plus is what? Nitrogen is 7, oxygen is 8, and 1 electron is removed. So this will give us what? 7 plus 8 minus 1 is 7. So 7 plus 7, this will give us 14. Cn minus is 7 carbon plus, so this is 6 of carbon. Then we have 7 of nitrogen plus 1 due to the added charge. So this becomes 6 plus 8, which is also 14. Then N2 is what? 7 plus 7, which also gives us 14. Cn minus is 6 plus 7 plus 1. So this gives us what? This gives us 14. And then O2 2 minus is 8 plus 8 plus 10. So this gives us, 8 plus 8 plus 2. So this gives us 18. Okay. So this is all that we have to assign. So C2 2 minus is 14. O2 minus is 17. So here itself it is not following. So this is not the right option. Then CO is 14 and NO is 15. Then NO plus is 14. C2 2 minus is 14. Cn minus is 14 and N2 is 14. So all have same number of electrons. So option B is the right answer. You can also verify the other options. We have already solved them. You'll find that there would be one or two, two species which will not have the same number of electrons as the other options, and therefore we can see that the B is the right answer. Then the ionization enthalpy of hydrogen atom is 1.312. So what is ionization enthalpy? The amount of energy required to remove an electron from the atom. So how do we remove an electron from the atom? So let's say we have the hydrogen proton, then we have electron in the hydrogen in the ground state. Now I have to remove this electron completely from the system. I don't have to keep it in another higher orbitals. I have to remove this completely from the system. So this is known as ionization enthalpy. Right? So this is ionization enthalpy. Now if I have to write down this in terms of the equation that we have, so what is the equation? So delta E is equal to, so this is in terms of joules. So if we have to write the equation in terms of joules, of energy is what? Energy is equal to, the electron is removed. So it is 1.312 into 10 to the power 6 joules. Okay, so this is the energy to remove when the electron is completely removed. Now I have to find out the energy when the electron, the energy required to excite the electron in the atom from n is equal to 1 to n is equal to 2. Okay, so the final state is n is equal to 2. So what is the energy? Energy is equal to 1.312 into 10 to the power 6. Okay, into z square upon n square. Okay, so this is electron, this is a hydrogen atom, so z will be equal to 1. So this will be 1.312 into 10 to the power 6 into 1 square upon, and the value of n is equal to 2, so 2 square. Okay, so this will give us 1.312 into 10 to the power 6 upon 4. So this gives us what? This gives us around, okay, so this gives us 3.28, 0.328. So this is 0.328 into 10 to the power 6. Okay, so this is our E2, right? Now all I have to find out the energy required to excite the electron from n equal to 1 to n equal to 2. So the energy to remove the electron is equal to 1.312 into 10 to the power 6 minus the energy required to take it to the second level is 0.3828. So the subtraction of this will give us the energy that is actually required. So the differences in energies, this gives us what? This is equal to, if we do the subtraction, is 0.984 into 10 to the power 6, which is what? If I have to shift this decimal, so this will give us 9.84 into 10 to the power. So I've increased the number, so I'll decrease this. So this will become 10 to the power 5 joules. So the right answer is option D. Next, calculate the wavelength in nanometer associated with a proton moving at this speed. Okay, and the other information is given. Now, what equation do we require for this? So the equation is lambda is equal to h upon mv. Okay, so this is the equation from the dual behavior of matter. So the wavelength is asked and we are giving the velocity. Okay, and the other terms are also given, so we have to just do substitution. So this will be 6.626 into 10 to the power minus 34 joule second upon what is the mass 1.67 into 10 to the power minus 27 kg, and what is the velocity 1.0 into 10 to the power 3 meters per second. Okay, so if I see, if I take the 10 to the powers together, so what we have 1.6 and 6.6. So all we have is 6.6 upon 1.6 into 10 to the power minus 34. Then we have plus 27 if taken to the numerator and minus 3. Okay, so this is what we have to solve. So if you see 1.6, so 1.6, which means if I take this, if I shift the decimals for both of them, so this will be what? 66 upon 16 into 10 to the power. So this becomes what? Minus 34 plus 27, which gives us 7, minus 7, and minus 7 minus 3 is minus 10. Okay, now 16 into 4 is 64. Okay, so this is a little greater than 64, which is 66. So approximately we can consider 4. So this gives us 4 into 10 to the power minus 10. Okay, this is in terms of meter. Now the values are given in terms of nanometer. So nanometer is what? 1 into 10 to the power minus 9 meter is 1 nanometer. Okay, so 10 to the power minus 9 meter is equal to 1 nanometer. So 4 into 10 to the power minus 10 meter is how many nanometer? Okay, so we'll have to cross multiply. So 4 into 10 to the power minus 10 into 1 nanometer upon 10 to the power minus 9 meter. So meter and meter get cancelled. 10 to the power minus 9 minus 1 becomes 10 to the power minus 1. So this is 4 into 10 to the power minus 1 nanometer. So this gives us what? 0.4 nanometer. Okay, so the right answer, if you see, is option A. Okay. Now the next question, in an atom, an electron is moving with a speed. So the actual speed of the electron is given with an accuracy of, so the percentage accuracy is given, right? Certainty with which the position of electron can be located is. So what is asked? So they are asking us delta x. Okay. And other useful information is given. So what we have to use, the equation that we'll be using is Heisenberg's uncertainty principle. So what is the equation? Delta x into delta v is equal to h upon 4 pi m. Okay. Now, if you see delta v, which is an absolute uncertainty value, is not given, but the percentage uncertainty is given. So if you see percentage uncertainty, which is 0.005%, which is upon 100 of the actual speed, will give us what? The absolute uncertainty. So this is percentage uncertainty into the speed. This gives us absolute uncertainty. Right? Now if I have to find this, so this will give us what? And the zeros will be after 3. So this is our absolute uncertainty. Right? Now if I know the value of absolute uncertainty, I don't know delta x. Okay, delta x into 0.03 is equal to what? We have to substitute the value of h, which is 6.6 into 10 to the power minus 34 upon 4 into 3.14 into the mass of the electron is 9.1 into 10 to the power minus 31. Okay, now I'll shift this 0.03, so this will go to the numerator. So I'll find delta x, so this will give us what? 0.03. Okay, right. So all I have to find out is this, and I'll be done. So 6.6 is what? 3.3, and 9 is 3. Then 3, 1.1. Okay. All I have to do is I'll have to do this division and I'll get the answer. So yeah, so if you actually solve this, I'll leave the solving up to you, because now we have done a lot of examples where we have actually solved the calculations, but then I'll leave this up to you. I'll tell you what is the final answer. So the final answer that we'll be getting is 1.92 into 10 to the power minus 3 of a meter. Okay, so verify this if you get or not. And so the right answer is option B. Okay, now the next question, the energy of electron is given by, if you see, the formula is also given in the question, and the wavelength of light required to excite an electron in a hydrogen atom from n is equal to 1 to n is equal to 2 will be. Right. So if you see, we are asked about the wavelength. Okay, so energy is given. So from n is equal to 1 to n is equal to 2. Now, what is the energy? So what is the energy in the second level? So energy will be minus in the second level. So this will be minus 2.178 into 10 to the power minus 18. So hydrogen atom, so 1 square upon 2 square. And what will be the energy in the first level? So this will be minus 2.178 into 10 to the power minus 18 into 1 square upon, in the first level, so this will be 1 square. So if I subtract the energy levels in the 2 level and the 1 level, then I'll get the energy difference. So this, I'll get delta E. So delta E will be what? E2 minus E1. Okay. So delta E is something which I'll be getting. What I can do is, I can also directly write, yeah. So, okay. So then what can I do is, I can just substitute the values. This will be minus 2.178 into 10 to the power minus 18, which is common. So this will give us what? 1 upon 2 square minus 1 upon 1 square. Okay. So delta E is what? H into C upon wavelength. Okay. This will be minus 2.178 into 10 to the power minus 18. And this will give us what? 1 upon 4 minus 1 upon 1. Okay. So if I have to solve this, I'll have to equalize the denominators. So this will give us what? HC upon wavelength is equal to minus 2.178 into 10 to the power minus 18 into, so this will give us 1 minus 4, which is minus 3 upon 4. So minus and minus signs get cancelled. So this will give us what? So I have to find out the wavelength. Okay, I'll take this wavelength on the other side. So I will have H, which is 6.62 into 10 to the power minus 34 into 3 into 10 to the power 8, which is the value of light, speed of light, and I'll take this value down. So this will be 2.178 into 10 to the power minus 18 into, so this will be into 3 into 4. So this will give us what? The wavelength, the value of wavelength, right? Now all I have to do is I have to solve this. So 3 and 3 get cancelled, 2 ones are and 2 twos are. So 6 into 2 is approximately equal to 12. Okay, and 12 into 10 to the power minus 34 plus 18 plus 8. So this is what I have to solve. So this will give us 10 to the power. So if I solve this, okay, so minus 15 and plus 6. So this will give us minus 7. So 12 into 10 to the power minus 7. Right? So this is what we get in the final this thing. I'm sorry, I made small mistakes. This should be 32 minus 18 is 16. So this will give us minus 8. Okay. But if you see, the values are 10 to the power minus 7. So if I have to increase it, so 10 to the power minus 7 is larger, I'll have to decrease this. So this will be what? 1.2 into 10 to the power minus 7. And if you see which is the right answer, so the right or the closer answer is option A. In the next one, the correct set of 4 quantum numbers for the valence electrons of rubidium atom is. So let's see, they have given the atomic number. All we have to do is, in such questions, we have to fill the Aufbau principle and find out where the valence electrons comes. Okay, so Aufbau principle. Right? Now Z is equal to 37 is where I have to stop. So I will have 1s2, then 2s2, and after 2s we have 2p6, 3s2, 3p6, 4s2, 3d10. So let me see where do I stop here. So this will give us what? 6 plus 4, which is 10. Then this gives us 6 plus 2, which is 8. So 10 plus 8 is 18. Then 10 plus 2 is 12. So 18 plus 12. So this gives us 13. So till here we have reached till 30. Now we have to go further. So after 3D, if I take more 4p6, so this will give us what? More 6. So this will give us in total 30 plus 6, which is 36. So after 4p, I have to go to 5s. So 5s, one more electron because it is 37. So this gives us 37. So the last electron is going in the s shell, and this is what they have asked, the valence electron. So for the valence electrons, the quantum numbers are, so n is equal to 5. L for s is 0. Then ml is equal to 0 again. And then ms can be plus half or minus half. But since here all the 4 options are plus half, we'll consider plus half. Okay, so this is matching to option A. So the right answer is option A. Okay, next. Which of the following is the energy of the possible excited state of hydrogen? So what is the energy for hydrogen? So for hydrogen, the general equation that we have is energy is equal to minus 13.6, and we have asked just for hydrogen, so this will be what? 13.6 upon n square. Okay, so minus 13.6 with n is equal to 1 is for the first level. So E1 is what? Minus 13.6 upon 1 square, which is equal to minus 13.6 electron volt. Now if I have to find out for E2, so this will be minus 13.6 upon 2 square. So this will be what? Minus 13.6 upon 4. So this gives us what? 3.4. So this will be minus 3.4 electron volt. So do we have this value? Yes, we have this value in the option A. So this is a possible value of energy. Now if you calculate for, so plus will never be a value. So plus values of excited state cannot be possible. And if you solve for even the third level or the fourth level, you will never get a value of 6.8. So the possible energy level is option A. Now, in this question, a stream of electrons from a heated filament was passed through 2 charge plates kept at a potential difference of V. So the potential difference that is applied is V. Okay, potential difference is equal to V. Okay, if E and M are the charge and the mass of the electron respectively, then the value of H upon lambda is. So this is what is asked ultimately. Okay, this is what we have to find. Now, what equation do we have to use in such a condition? So if an electron is passed through, with a potential difference of V, so what equation do we have? Let's say wavelength is equal to H upon mv is one equation that we have. But then if I have to find out the energy, so energy is what? Half mv square. Okay, so energy is this. So if I multiply this with m by m, so this will give us what? Energy is equal to m square v square upon 2m. Okay. Now, so m into v. Okay. So this is what? Energy is equal to mv the whole square upon 2m. Okay. Now mv value is what we know. So mv is what? mv, if I take on the other side, I'll get h upon lambda. So this is equal to h upon wavelength, mv. And this is what we have to exactly find. So the energy will be what? H upon wavelength, the whole square, into 1 upon 2m. So all I have to find is h upon wavelength. So energy is what? Now also the energy is equal to potential into the charge of electron. So this is the value of energy. So I'll substitute this: potential into charge is equal to h upon wavelength square into 1 upon 2m. So I'll shift this. So V into E into 2m is equal to h upon wavelength squared, right? So h upon wavelength squared is equal to 2meV. Okay, now I have to just find h upon lambda. So h upon lambda would be what? Taking square root on both sides. So square root and square get cancelled. So h upon lambda is what? Under root of 2meV. So if you see which is the right answer, so the right answer is option B. Okay. In the next question, the radius of the second Bohr orbit for hydrogen atom is. Now the second Bohr orbit is asked. So what we have to do is, all we have to do is apply the equation of radius. So what is the equation for radius, if you remember? It is radius is equal to 0.529 into n square upon z square. Okay. So since hydrogen atom only is asked, so z is what? Z will be equal to 1. And the value of radius of second Bohr orbit. So it is asked as the second Bohr orbit. So for the second Bohr orbit, n value will be equal to 2. Okay. So this is what I have to find. So this will be 0.529 into 2 square. So this will be 0.5, sorry, this is 29 into 4. So this will give us what? All I have to do is I have to just multiply. Okay, so 2.116, and this value is in angstrom. So the final value that I have is in angstrom. Okay, so if you see which is a closer option, option D. So 2.116 is approximately 2.12 angstrom. So option D is the right answer. Okay. See, isoelectronic is one thing which is repeatedly asked, and this is the reason why I have shown you that every year, be it any year in the previous years, around in 1990s also we have seen this question, and a very recent year which is 2017 also has this question. Okay, okay, so fine, let's solve this. So if I have O2 minus, so this is what? 8 plus 2, which is equal to 10. If I have F minus, this is 9 plus 1 is equal to 10. Then if I have sodium plus, so this is what? 11 minus 1, which is 10. And magnesium 2 plus, which is 12 minus 2, which is again 10. So all of these in the first option itself is isoelectronic species. So option A is your right answer. Okay. Next. Now for the emission line of hydrogen atom from Ni is equal to, so the initial state is 8 to Nf is equal to N. So from 8th level, it is going to some level N, which is not mentioned. So we have, so these are the different levels. Okay, so this is 1, 2, 3, 4. Likewise, we have 5, 6, 7, and 8. So Ni is equal to 8. So electron is present here, and it is going to some value which is N, which is not mentioned. Okay, the plot of wavelength versus 1 upon N square will be. Okay, so wave number is given. So what equation do we have with wave number? So wave number is equal to 1.0976 into 10 to the power 7, 1 upon Ni square minus 1 upon Nf square. This is the equation that we have. So if I have wave number is equal to 1.09, it is actually 1.09677. Okay, 677 into 10 to the power 7. So the initial value is given. So this is 1 upon 8 square minus 1 upon Nf square is N. So 1 upon N square. So this will give us what? Wavelength is equal to 1.09677. So we'll multiply this value to both the numbers upon 8 square minus 1.09677 into 10 to the power 7 upon N square. So what I have to plot? I have to plot wave number versus 1 upon N square. So 1 upon N square is what I have to plot. Okay, so this is 1 upon N square. Now this is what I have to plot. If you see, this is Y and this is a constant. So this will be C. We have a minus sign, and 1.09677 into 10 to the power 7 is a constant, which is M, and this is our X. So if you see, this is a straight line, and if X has a negative sign, which means the line is a decreasing line. Okay, so this is how the line will be. It has a y-intercept which is c. So the slope is what, and this m value is what, the value of Rydberg constant. So this will be my RH. See, linear. So the line is linear. Okay, we know this is a straight line equation. So linear is the right option amongst these two. These two are definitely not the option. This is not the option. And the intercept is RH upon 8 square. So linear with intercept minus RH. No, intercept is RH upon 8 square. Non-linear is not the option. Linear with slope RH? No, the slope is minus RH. The slope with minus RH is option D. Okay. Then the isotopes of hydrogen are. Now, one thing that you have to remember, the isotopes of hydrogen, what are? So, hydrogen has three names, which is protium, deuterium, and tritium. Okay. So, what are these three? So, protium is 1H1, deuterium is 2H1, and tritium is 3H1. So, this has number of neutrons, number of protons is equal to 1 in each case. Number of neutrons. So, number of neutrons is 0 in this case, 1 in this case, and 2 in this case. And therefore, we have the atomic mass number as 1, atomic mass number as 2, and atomic mass number as 3. So these are the three isotopes of hydrogen. So if you see which contains of these three options, so this is the option C. Protium, deuterium, and tritium. Fine. Now for this question, for a given series of spectral lines of atomic hydrogen, let delta nu be V max minus V min. So what we have to find out? We have to find out delta nu, which is wave number. So this is maximum wave number minus minimum wave number. Okay, be the difference in maximum and minimum frequencies in centimeter inverse. Then what we have to find out? We have to find out the ratio of this delta nu, which we'll be doing the maximum minus minimum for Lyman, and upon this delta nu bar for Balmer. Okay, so first we'll find out the delta nu bar for Lyman. Okay, so what we have to find out for this, we should know the nu max. So what is the maximum wavelength, maximum frequency? Maximum frequency is when we have the transition. So for Lyman, the transitions are from n is equal to 1 to n is equal to, so initial is I is 1 and nf can be any value, so 2, 3, 4. So maximum difference in energy will be what? When this value is infinity. So from n is equal to 1 to n is equal to infinity, we'll have the maximum frequency. So if I write in terms of centimeter inverse, so this is 1 upon 1 square for Lyman minus 1 upon infinity square. Okay, so this is maximum. So 1 upon infinity square is infinity. So 1 upon infinity is 0. So this will give us what? 1.09677 centimeter inverse. So this is maximum for Lyman. Now if I want to find out the minimum for Lyman, so nu minimum will be what? The minimum difference in energy, which will be n is equal to 1 to n is equal to 2. So this will give us what? 1.09677 into 1 upon 1 square minus 1 upon 2 square. Okay, so this will be 1.09677 into 1 minus 1 upon 4. So this will give us what? I have to just equalize the denominators. This is 4 upon 4, which is equal to 1.09677 into 4 minus 1 upon 4, which is 3 upon 4. Okay, so this will be what? 1.09677 into 3 upon 4. So this is delta, not delta, but nu minimum for Lyman. Now I have the maximum value and I have the minimum value. All I have to do is subtract. So delta nu is what? Nu bar is nu max minus nu min. Okay, so this is what? This is happening for Lyman. Okay, so if I want to find this, I'll just maybe erase this part. So what I have? Delta nu bar is equal to what is the maximum? 1.09677 minus minimum is 1.09677 into 3 upon 4. So what I can see in both the terms, 1.09677 is common. Actually, this is 10 to the power 7 in both the cases. I forgot this. Okay, so into 10 to the power 7. So this is common into 10 to the power 7. So in the first term we have 1 minus 3 upon 4. Okay, so this is 3 upon 4. So this will be 4 minus 3 upon 4, which is 1 upon 4. So this is the delta nu for Lyman is 1.09677 into 10 to the power 7 into 1 upon 4. Okay, so this is something which is important to me. So this is what I'll be using now in a while. So first I'll find out for Balmer, and then I'll find out the ratio. Okay, so for Balmer I'll first find out. So Balmer series starts from what? So Balmer series starts from n is equal to Balmer series starts from Ni is equal to 2. Okay, so the Balmer series for maximum will be what? 2 to infinity. So mu max for Balmer will be 1.09677 into 10 to the power 7. So the initial value would be 1 upon 2 square and the final value would be 1 upon infinity square. So 1 upon infinity square again becomes 0. So nu max for Balmer is 1.09677 into 10 to the power 7, 1 upon 2 square, which is 1 upon 4. Then if I have to find out minimum, which is from 2 to the adjacent one, so from 2 to 3. So this will be 1.09677 into 10 to the power 7. So this will be 1 upon 2 square minus 1 upon 3 square. So this will give us what? 1.09677 into 10 to the power 7, 1 upon 4 minus 1 upon 9. I have to equalize these. So I'll multiply this by 9 upon 9 and this 4 upon 4. This will give us what? 1.09677 into 10 to the power 7. This will give us 9 minus 4 upon 36. So this will give us 5 upon 36. So 1.09677 into 10 to the power 7, 5 upon 36. Okay. So this is new minimum for Balmer. I have to do the subtraction of new max and new min. So this will give me what? So nu max, so delta nu is what I have to find out. So delta nu will be nu max minus nu min. Okay, I can erase this part and do the calculations here. Okay, so I will have maximum is delta nu is what I am finding. So this is for Balmer. So delta nu bar for Balmer, maximum minus minimum. So 1.09677 into 10 to the power 7 into 1 upon 4 minus minimum is 1.09677 into 10 to the power 7 into 5 upon 36. Okay, so this will give me what? So I'll take this common 1.09677 into 10 to the power 7. I will have 1 upon 4 minus 5 upon 36. So this is what I have to do. So I'll have to multiply this by 9 upon 9. So this becomes 36 denominator. So this will be 9 minus 5 upon 36, which will give us 4 upon 36. So the subtraction will give us 1.09677 into 10 to the power 7 into 4 upon 36. So this is our delta nu for Balmer. Okay, so these are the two equations. Now I have to take a ratio of these two equations. If you see delta nu of Lyman upon delta nu of Balmer. So this is what I have to do. Right, now I can again erase this part. So delta nu of Lyman upon delta nu of Balmer. So this will be 1.09677 into 10 to the power 7 into 10 to the power 7 into 1 upon 4. Okay, and the Balmer is 1.09677 into 10 to the power 7 into, so this is 4 upon 36. Okay, so these two terms anyway get cancelled. So this will be what? Multiplied by the reciprocal 1 upon 4 into, I guess I've done some mistake. So this was actually what? 9 minus 5. Okay, I guess I've done some mistake for Balmer. So the maximum for Balmer was what? 1.09677 into 10 to the power 7 into 1 upon 4. So this was the maximum and the minimum was 5 upon 36. So if I do a difference of these, so this will give me what? 1 upon 4 minus 5 upon 36. So I have to multiply by 9 upon 9. So this will give me 4 upon 36. Okay. So this will actually be, yeah, so this is fine. This is fine. So this is what actually 4 ones are and 4 nines are 36. So I have to multiply by the reciprocal. So this will be 1 upon 4 into 9 upon 1. So this will give us what? 9 upon 4. So the value of delta nu bar Lyman upon delta nu bar Balmer is equal to 9 upon 4. So which is the correct option? So the correct option is option E. So this is all about the questions of the previous years. I've taken maximum questions and questions such that they are very different and they will give you an idea of how the questions are. You can also look for more questions and solve for yourself. And that's it for this chapter. And then in the next video, we'll be starting with a new chapter. So thank you.